Hello, everybody. Today we're going to look at the answer to the chapter 11.1 Bellwork I put up. Basically, it was a cylinder rolling along on flat ground. It goes up a hill that's 3 meters tall. It started at 10 meters per second. And the question is, what is its velocity at the center of mass at the top of the hill? We ended up being given the mass and the radius of the cylinder. But it turns out, you'll see in my solution that you don't actually need that information. You can solve it by canceling stuff out. So what I thought I would do is try showing you guys my solution and taking you through what I did. Okay, so let me swap out this board for my solution here. Okay, so for my solution, you can see we're starting with energy. So we start with kinetic energy, linear and rotational. And then after it gets up the hill, it's still moving forward. It still is rotating, but now it has potential energy as well. So when I pop in the equations for this, we get 1/2 mv initial squared for initial linear kinetic. We get 1/2 I omega initial squared for the rotational. And then very similar for the final. It's just final stuff. And then over here, we get mgh. Now, you can see I put a 2 in front because that canceled the halves in front of all the other terms. Okay. The next thing that I did is I popped in I, 1/2 mr squared. As well, omega is v over r. So I did omega initial is v initial over r, and then you square them. And keep in mind, this is just the radius of the cylinder. If this was a ring, you would always use the outer radius, the outermost point. On the other side of the equation, you can see we're doing basically the same thing. And then over here, I've got 2 mgh. But then once you do this, you can cancel the m's in every term. So then we're left with v initial squared plus 1/2 v initial squared equals v final squared plus 1/2 v final squared plus 2gh final. So then I got down to here and I just started to simplify a little bit. I plugged in the initial speed of 10, plugged in the height of 3, 9.8 because we assume we're on Earth, and then finish out the math and you get about 7.8 meters per second. Then if you want to know what the omega is at the top of the hill, this would technically be omega final. Let me add that in. So we're talking about final velocity at the top of the hill goes with final omega at the top of the hill. And you can see that's pretty easy. You just divide by the radius of 1.2. So I said at the beginning we didn't really need the radius, but actually we do need it here at the very, very end. But if you guys look back in the problem, r cancels here, and then the mass cancels in every term. So it's a pretty simple problem once you set it up from conservation of energy. Hope this helps. I will see you guys next time.